Hi there. So my goal with this channel is to make data feel less vague, and more approachable, especially if you're trying to pivot or you're exploring it as a career path, or you're just curious about how data works behind the scenes. So today we're going to talk about data repositories, a term that simply refers to where your data lives, whether it's for day-to-day operations, decision making, or advanced analytics. So let's get on with it. A data repository is a storage location where data is collected, structured, unstructured, and kept accessible, whether it's for operational use or analysis. These repositories can range from traditional databases to more advanced systems that support large-scale, high-speed processing. In this video, we will take a high-level look at the main types: databases, data warehouses, data marts, data lakes, big data stores, and the data lakehouse. Let's start at the foundation with databases. A database is designed to store and organize data in a way that makes it easy to access, manage, and update. These are managed using database management systems, which let you store, retrieve, and manipulate data, often through structured queries written in SQL. There are two broad categories of databases. We have relational databases, RDBMS, and non-relational databases, that is also called NoSQL. Relational databases organize data into tables, that is rows and columns, with strict rules and defined schemas. These work well for structured data like transactional records or financial logs and the likes. But as data grew more complex, think social media posts, logs, sensor outputs, we needed more flexibility. That's where NoSQL comes in. NoSQL databases are designed for scalability, speed, and variety. They allow you to store data without a fixed schema, which makes them ideal for semi-structured like JSON and XML, and unstructured data like images, videos, and free text. Now let's talk about data warehouses. A data warehouse acts as a centralized system for integrating data from different sources. Through a process called ETL, that's extract, transform, load, data is cleaned, modeled, and stored for analytics. Warehouses are designed for historical analysis, trend reporting, and business intelligence, and they can typically use structured data formats. Popular cloud-based data warehouses include Snowflake, Amazon Redshift, Google BigQuery, IBM DB2 Warehouse. Next on the list is the data marts. A data mart is a subset of a data warehouse designed for specific teams or functions like marketing, HR, finance, and the likes. They offer faster access to relevant data and reduce unnecessary complexity. There are dependent data marts, which is sourced from a warehouse, independent data marts, built from raw data sources, and hybrid data marts, which is basically a mix of both. Next, we talk about data lakes. Data lakes can store huge volumes of raw data, whether it's structured, semi-structured, and unstructured, all in one place. The key difference, you don't have to define the data structure before storing it. This schema-on-read approach makes data lakes ideal for data science, machine learning, and advanced analytics. Data lakes often use cloud object storage like Amazon S3 or distributed systems like Hadoop, and they can handle a wide variety of data formats, from CSV files and logs to PDFs and images. Next, we talk about big data stores. Big data stores are built to scale horizontally and process data at high speeds. They're essential for managing the V's of big data. We're talking about volume, that is large data sets, velocity, that is real-time streaming, variety, that is different types of data. Technologies like Apache Spark and Hadoop enable parallel processing and distributed storage, making them powerful for large-scale analytics. Finally, let's talk about the data lakehouse. From the name, you can tell the data lakehouse brings together the strengths of data warehouses and data lakes. It gives you the structure and consistency of a data warehouse with the scale and flexibility of a data lake. That means you can store all kinds of data Use it for both BI dashboards and machine learning, and manage it all from a single architecture. Now let's talk about choosing the right data repository. When choosing a repository, you need to consider the following. 1. What kind of data are you storing? How will the data be used? Operational reporting, real-time dashboards, deep analytics? Do you know the schema in advance, or does it need to remain flexible? How fast do you need access to insights? What's the data volume, and do you expect it to grow rapidly? There's no one size fits all. The right solution depends on your goals, infrastructure, and use case. Thanks for watching. So if this helped clarify things for you, don't forget to give a like, drop a comment, and subscribe. Bye.